we talked about the idea of association and correlation and what that means with respect to a scatter plot. And we're talking about the strength, the direction, the association as being the three characteristics that we really want to identify. So let's take a look at an example. So we have some data that shows a relationship between a male's age in years and his HDL cholesterol level, the good cholesterol. And it's measured in milligrams per deciliter of blood. So this is the age, and then we have the HDL cholesterol. So this is basically like a matched pair, all right? So this is the same subject, this is the, same subject, etc. So number of things that we want to do. Define the response as well as the explanatory variable, build a scatter plot, describe the association, what can be said about the general relationship, and then if there's any lurking variables, we have to explain those as well. So for letter A, I think it's pretty obvious that the age is going to be the predictor of the HDL cholesterol level. All right, so we're going to say that the explanatory variable is going to be the age of the male, and the response is going to be the HDL cholesterol. All right, and I know I spelled it wrong. All right, next thing we're going to do is we're going to construct the scatter plot. All right, so that should be pretty easy. So we're just going to draw a scatter plot for this. All right, so that's just going to be an axis that looks something like this. On the x-axis, we have our age of our male, and on the y-axis, we are going to have the HDL level. I'll just say HDL cholesterol. Notice that the lowest observation for males is 38, the highest is 61. So let's just go in increments of 10. So we have 30, 40, 50, 60. For HDL, the highest we have is 57, the lowest we have is 38. So let's just start at 30. So 30, 40, 50, and 60. And we're just going to do like a Cartesian plane. We're going to plot the points. So we have 38, 57. It doesn't have to be great, but we're going to do our best. So up here, we have approximately this coordinate. So that's 38, 57, 42, 54. So we go over to 42 and then 54. That'd be right about here. All right. And again, it doesn't have to be super accurate, but, and we'll see later how to make a more accurate plot. 46, 34. All right, so we're going to go over to 46, and then we're going to go up to 34. All right, so 46, 34, maybe right about here. All right. 32, 56. So 32, 56 is going to be right about here. All right. And 55, 35. So 55 and 35 is right about here. 5240, right about here, as best as we can. Oops. 6142, all right, so that's going to be right about here. And finally, 6138, same place, except it's going to be maybe right about here. Okay, so we kind of get this relationship that the lower the age of the male is, the higher the HDL cholesterol. And then it looks like as we go on, it starts to get a little bit lower with age. All right, so describe the type of association. All right, so let's go ahead and do that for part C. So for part C, we're looking for, keeps wanting to change it, that's fine. Not that it matters that much. So we're looking for strength, direction, and the association. All right, so the strength of this thing, remember, we either say strong, moderate, or weak. Now, I think the best thing to do is to answer the question if it's linear or not. Okay, so let's start with association. Is it linear? And here's the way I think about linearity. If it looks like it's trying to form a line, and maybe you can take out 2 or 3 points and it starts to become a really good line, especially with smaller sets of data, then it's probably linear. All right, so now I'm going to redo this. But what if I took out maybe this point and maybe this point? Well, it looks like a straight line, even if I took out this little guy right here, it looks like it almost forms a straight line. So just by putting those points back in, it doesn't really alter the shape of the curve too much. We're looking for the best description. All right, so the association is indeed linear. All right, and that's probably the first thing that you always want to do, describe the linearity or nonlinearity. The strength of it, how close is it to forming a straight line? Well, there's some points that kind of skew that line, but it's not a terrible line. So we would probably say moderate if we were to answer that question. And the direction, because they are inversely proportional, because the age increases, the HDL level decreases, we're going to say negative. All right, so that's one of the things that we always want to make sure is that we describe the type of association and then whether it's positive, negative, strong, moderate, or weak. All right, what can we say in general? Well, I think it's pretty obvious that from our data, it seems that there is an association between age and HDL cholesterol in the males, okay? And what that is that in general, as age increases, HDL cholesterol decreases. And according to this data. All right, so now if we got another 7 observations or 8 observations, it might tell us something completely different. All right, so we have to be careful when we're describing our data. Now, the last thing that we always are interested in, what are these lurking variables? All right, so are there any lurking variables that could explain HDL cholesterol level? All right, and certainly there are. All right, so one thing that usually predicts what your HDL cholesterol level is going to be your diet. Okay, so do you have a good diet? Or is your diet kind of poor and you eat a lot of saturated fats or trans fats, etc.? That can really boost up that or to reduce that HDL cholesterol and make the ratio not too good. All right. Another one is going to be your level of activity. Generally, people that are sedentary and don't have a lot of activity are going to be more suspect or more likely to have a lower HDL cholesterol level and a higher LDL cholesterol level, the bad type. All right, so we always have to think to ourselves, yeah, this does explain it, but is it really the best explanation? All right, and so we generally know as we get a little bit older, maybe our level of activity decreases, or maybe we just tend to eat a little bit worse just because we don't have time to eat right because we're stressed out or something like that. So we always have to think about these things as we're going through these types of analysis of bivariate data. All right, so hopefully this gives you a good overview as to what bivariate data is and how we can use a scatter plot to analyze it. In the next section, what we're going to do is we're going to start putting numbers to these types of scatter plots. And we're really going to see what can we do to give a more precise explanation about the strength, direction, and association of a scatter plot.